So we continue to move through our decision tree looking at how to decide what type of data visualization to use. In previous videos, we looked at parts of a whole, whether it's one variable or two variables, which led to things like pie charts. Then we looked at comparing the responses within a variable, or whether we are comparing two or more variables, and that led to column charts and bar graphs. Then we looked at measurements of time. And so we looked at different ways to represent time, whether time was discrete or continuous. We looked at line graphs and bump charts and dot plots. If we continue to move along our graph, we see that the next set of graphs are based on location. We're going to leave those for now because once we finish our data visualization discussions, we're going to get into data types and sources of data and the type of analysis you do depending on whether you're dealing with text or whether you are dealing with spatial data, longitude and latitude. So we're going to reserve these visualizations location-based for some later videos. Some examples of location-based visuals are Voronoi polygons, heat maps or choropleth maps, and bubble maps. We'll come back to those. So let's continue our moving along our decision tree here. If we are looking at variability, so we want to know how much differences there are in the data. We are looking at things like distributions. If we have one variable and the data is ordinal, so we have ranking, and we want to see how different people ranked a question, then we would create a box plot. If we have ratio type data, then we want to create a histogram, a density plot, or a B-swarm. We can also create that box plot for ratio or interval data, not as common, or we can create a violin plot. So that's if you have one variable. If we have two variables and we have nominal and ratio data, so we have categories and we're looking at ratio data for those categories, essentially all we're doing is creating multiple density plots or multiple B-swarms or multiple violin plots. If we have two variables, one is nominal and the other is ordinal, so we're looking at how one group ranks versus how another group ranks, then we're simply just creating multiple box plots. So whether you have one variable or two, you're still really creating the same type of graphs when it comes to variability. So in this video, let's look at how to create a histogram, a density plot, a B-swarm, a box plot, and a violin plot. All right, so just a reminder, if you're wanting to graph along with us, you can find the worksheets at drstephpowers.github.io/BIA, and we're working through this data visualization workbook. When you log into here, log in, if you just click in, no logging in required, you will not only find the workbook that you can open using Google Colab, but you'll find we're also using Bargain Numeric, Bargain Clean, and CRM Clean files, Excel spreadsheets. And so make sure you grab those as well. They're listed here on the left. Save those, dump them into your Google Drive. So when you open Google Colab, you can mount your own Google Drive so they're linked. And then you can pull the data sets. And we're using this method so that if you decide to do analysis for your own data sets, you know how to get them from your Google Drive as opposed to linking them to GitHub. All right, so let's dive in. And we'll start with the histogram. So when we're looking at a histogram, we are using Seaborn and we're calling it SNS. So let's import that package. And remember, the histogram is used where we have one variable and we want to look at variability within that one variable. It needs to be a variable as we saw on our chart. So our histogram is used when we have ratio or interval data. We're using a histogram. So if we go back here, let's look at data frame 2. So this is the bargaining survey that has been coded. And here with DF2, we're looking at question 24. So question 24 was, how many years have you been with the company? So it is a numerical open-ended question where they wrote in a number, which gives us ratio data, 0 being you're not at the company. So we're going to create a figure using SNS, and the command is histplot. And then all you have to do is give it the variable you want to create a histogram for. Now we're going to format this. We're going to call the x-axis years with company, okay? And then for the y-axis, we can start out with no formatting. It's kind of how we start off, see how it looks, see what the histogram looks like, okay? And so we could say, well, you know, that's a lot of information there. Maybe we want to clean it up a little bit. And so we want to go from 0 to 40 in increments of 5. So let's just give a little bit more space up here. And so remember, when you do this, we're using NumPy, so we need to make sure we have also imported NumPy as NP. We already have this running, of course, because we've been using it for a bunch of other ones, but make sure that you have done that in case this is the first graph you're building. And so let's run that. This says that we're going to create a range from 0 up to, but not including 40. And we're going to do it in increments of 5. So it's going to add a little bit of space here by going and including 35. So you can see that just gives a little bit more space on the graph. So when we look at a histogram, we want to see is how much variability there is. You can see it goes from 1 to 30. And you can see the majority of people who work at the company have been here less than 5 years. So here we have our mode, the most common, is in between 0 and 5. And so the setting that we have right now in this histogram is it's automatically going to pick what are called the bins, how it's going to group the data. So here you can see it's grouping in 5-year increments. So we can see that there's about 5 people who've been here between 25 and 30 years. There's just less than that for the 20 to 25. And so you can see that there's kind of nobody here, just one person who's been here around 20. The majority is here. So we can see the spread. We can see where it tends to congregate, okay, with our histogram. We can get similar information with a density plot as you do with a histogram. A density plot in comparison kind of smooths it out. There is a downside to the density plot, in which case it's going to put the rest of the wings of the graph of the distribution. And so sometimes it will put that below 0, which is not a possible answer. So while the density plots look prettier than, say, the histogram here, it does add information that is not realistic. So let's look at how to do a density plot. To do a density plot, we are doing Seaborn. And so we're going to call that SNS, and we're using matplotlib.pyplot as PLT. So we need to make sure that we have loaded our packages. And then we said a density plot and a histogram can be used when you have one variable, question 24. But a density plot can also be used when you have 2 variables. So we could have question 2 and question 24. Question 24 is the interval ratio that shows how many years people have been here. And we can combine that with a nominal variable, question 2, are you part-time or full-time? To create a density plot with our 2 variables, we are going to create 2 data tables. One is going to be our data frame 2, that is the cleaned, coded bargaining survey, and we're going to pull it where question 2 is equal to 1. So these are the part-timers. We'll create one table of part-timers, and then we're going to create a second table of just the full-timers where question 2 is equal to 2. Okay. Now you could do this with the uncoded data instead of saying, so we could do this, and I'll just show you here, code densept.head. What we really care about is question 24. That's the nominal interval. We're just trying to separate out the 2 groups. And in this case, with the coded data, we have question 2 is written as 1 or 2. If instead you use the uncoded data set, where question 1 was equal to part-time, and question 2 is equal to full-time, we could do it this way. Oops, sorry. They got to be the same. They got to be the same table. All right, try that again. Okay, and then we could pull this. And when you do, you'll notice that question 2 is now just all the part-timers. So instead of 1, it says 2. But question 24 hasn't changed. It's still a number. I guess you can't really see that because my head is covering it. So it doesn't actually matter whether you're using the coded or uncoded data set here, because what we really want is just question 24 separated by the 2 groups. So it doesn't really matter if you use the coded or uncoded. Once you have that, once we have a table that is the part-time and a table that is the full-time, we're going to then create our 2 density plots. So we're going to set a style. And we're going to do dark grid. So it helps to be able to see the histogram by having kind of the shaded background. And so it is a style setting. Style equals dark grid is the dark color you see in the background. So we set that just to make it look a little nicer. And then what we're going to do is we're going to create a figure using our Seaborn SNS. The command is KDE plot. We are then going to pull question 24 from our part-time table. Fill equals true, and color equals, and then here is red, and here is blue. So that R is for red, that B is for blue. And this is so you can tell the 2 apart. Then we're going to have a second figure, and we're going to do the same thing. Take Seaborn, command KDE plot. We're going to pull question 24 from our full-time table. Fill equals true, and this time color equals blue, just so we can see the 2 different density plots. Then we need a legend. Our legend is going to label part-time and full-time. It needs to be in the same order as you are plotting. So whatever is your first plot needs to be labeled here. Whatever is your second plot needs to be labeled here. So part-time, full-time. We're going to locate the legend in the center and below the graph. Number of columns equals 2. That's so it can all be in a row, part-time and full-time side by side. All right, let's plot that. Notice we didn't have to specify what is on the X or Y axes. It's automatically doing the labels here. We can replace them if we want. The key here is to look at the part-timers. There's less variability than the full-timers. So full-timers range quite a bit. The part-timers are more congregated together. Now the challenge with the density plot is there's no one who's been here for minus 10 years. And in fact, we know that the longest someone's been here is, I think it's 29 or 30. But notice the tail keeps going. And that's because when it smooths it out into a distribution, it finishes it off. So if you think about this here, if we were to draw this, think about drawing a line, then it would then have to taper off past this point here down to 0. And so because of that, it's actually looking like it's adding data points with the density plot. So you got to be a bit careful with the density plot, is because it continues to go all the way down to 0 on the wings, the tails, that it starts to look like, oh, well, the full-timers, there's some -5 people. People have been here for -5 years. So in this case, because those numbers are not possible, you would probably want to stay away from this type of data visualization for the type of information we have here. For other information, let's say it's measurements where we have a lot of fractions of numbers, the density plot is probably a better way to go than a histogram. Histograms work really well when it's more counts. And then here the density plot works really well for these measurements where those continuous values are possible. So we looked at a histogram, we looked at a density plot. Let's look at a violin plot. And in fact, we've already done a violin plot when we were doing our inferential statistics. So you already know how to do this, right? All right, so we need from Seaborn, we need to import violin plot. And we need to import matplotlib.pyplot as PLT. So those are the packages you need for your violin plot. And if we go back here to our table, remember the violin plot here is used when we either have just one variable that's ratio or interval, can be used if you have nominal and ratio. It can also be used with nominal and ordinal. So let's look at our violin plot here. Let's look at question 17 and question 23. So we're working on, let's just make sure we're in the right thing. So this is data frame 3. So this is the customer relationship database. So let's make sure we look at the right one. Customer relationship database, question 17 and question 23. Question 17, talk to listening ratio for April. So here's our interval or ratio data. This is going to be the percentage of time in a minute that the salesperson is listening. And here we have our data that is customer relationship, very good, good, average, or at churn risk. So we want to know, for example, is the listening time different depending on the relationship? Maybe there is a relationship between how much our salesperson listens to the customer and the type of relationship they have with the customer. So let's take a look. So we're going to take our data frame 3, our customer relationship database here. On the horizontal here, we're going to do question 17. That's the percentage listening in a minute. And then what we're going to put on the vertical is question 23, which is the relationship. And if you recall, if we go back, this database here, DF3, is not coded. So when we look inside here for question 23, does it show up? Maybe not. Let's do question 23. You'll notice that it's words, it's text, it's strings. And so here we have average good, at churn risk. And so those labels are what's going to be on the left here. So we didn't have to code it. We can use the uncoded data here for our violin plot. We have our ratio data and then our nominal data here. Nominal or ratio here. Okay, hue, different colors. So we want to say, how do we want it to color code? We want it to color code based on the different groups. So you see Y is Q23 and hue is Q23. And then you can pick a palette, and I'll let you Google the SNS, the Seaborn palettes. There's different color schemes. Spectral here is these kind of oranges and greens. And legend equals false. We don't really need a legend here because we can see this is very good. This is at churn risk. This is good. This is average. Okay. And we can plot a Y label or relationship. We can plot an X label. That is our listening. Notice here that the order doesn't quite make a whole lot of sense. It's not in the ordinal. It's treating it very much as nominal and as each category as opposed to ordinal, where we would put the very good at one end and at churn risk at the other. So it's not ordered necessarily in the order that we want. If it was treated as ordinal data. But we can do a comparison here. So with the violin plot, this little center line is the median. The left of the box is the first quartile, so 25% are below that spot. The end of the box, the right side of the box, that point, there's 25% above it, so that's the third quartile. And we also get a bit of a density plot here, so you can see where the data tends to congregate. So we can find the mode, the most common, and you can see the general distribution. So we can see, for example, those who have a very good and a good relationship look like they're listening on a median, and most likely they're sitting around 40. Okay, and we had said, I think in a previous video, that ideally, oh no, that was talking speed. So never mind. So here we can see that more listening seems to go with a good and very good relationship. The average relationship seems to have less listening. The at churn risk seems to have a lot less listening. And we can even see down here where there's even very little listening, it has an at churn risk. So we could then do some inferential statistics to see if the relationship and the listening, if the amount of listening is related to the relationship, is that statistically significant? It does look like the less listening, the more the risk that you're going to lose the customer. And so we're exploring the data, we're describing what's happening, and so we can see here with our violin plot that the less people listen, the poorer the relationship. All right, so we've done a histogram, we've done a density plot, we've done a violin plot that combines a box plot and a density plot together. Now let's look at just creating the box plot. To create a box plot, we import matplotlib.pyplot as PLT and import numpy as NP. For a single variable box plot, we are going to do plt.boxplot. And here we're going to plot question 17 from our first data set. So question 17 was the amount of overtime hours in our survey about bargaining. Now the box plot does not deal well if you have missing information. So we have a single variable here. We're going to take data frame 2 and we're going to drop the NAs for question 17 and plot just the information that is available. Then we're going to label the y-axis as hours of overtime. The X mark here, this is 0, this is 1, this is location 2. If we didn't say that the X tick should say overtime, it would simply just have a 1 here because this is location 0 and location 1. So we say replace location 1 with the word overtime, and that gets us this label here in the right spot, and then plot it, show it to us. What this box plot shows us is this orange colored line is the median, second quartile. In this case, notice that our box and whisker plot has no whisker on the left side, and that's because the first quartile and the median are 0. So more than half of our survey respondents are not doing any overtime at all. Our third quartile is here at 5 hours. So that means 25% of our respondents had more than 5 hours. And so then we can see the rest of our range here. There are 2 that are flagged as anomalies or outliers. One individual, it seems, had 15 hours of overtime and another had 20 hours of overtime, which is not in keeping with the greater group. So the box plot shows you if there's anomalies. The one thing the box plot does not show you is how many people this is. Okay, so this could be more than one person, this could be more than one person. We just know that it's really rare because it's outside of our whiskers. Okay. You can use the box plot to create multiple box plots. So if we have multiple variables, so for example, we could take that question 17 about the number of overtime hours, and we could look at, is there a difference in overtime hours between people at the north location, the south location, and the east location? We would import Seaborn as SNS. We also are going to need to import numpy as NP. So we need to make sure both of those are running. We are using Seaborn, so we're using SNS. We're going to say figure equals SNS.boxplot. And then we're going to specify that the X is question 23. So that means that here we're going to have it be north, south, and east. Notice we are using DF2 in this case. We are using the coded data set. And question 17 is what is on the y-axis. That's going to be the number of overtime hours. For our y ticks, just to clean it up a bit, we are going to use that numpy package to create a range between 0 up to, but not including 30, and have it in increments of 5. The X label, the horizontal, is going to be labeled location. The Y label is going to be hours of overtime. The last piece here is that we have coded data, so the numbers for question 23 are actually 1, 2, 3. We don't want to say 1, 2, 3, we want to say north, south, east. And so we're going to replace based on position. So this is the 0 position, the 1 position, the 2 position. We're going to have it say north, south, and east. So when we run this, we get a box plot that looks like this. What you see here with north and south is not only are 25% of the respondents having 0 overtime, but 50% of the respondents have 0 overtime. And we don't even see a top of the box, so 75% are seeing no overtime. In fact, overtime is super rare in the north. We can see that there's really only 3 data points there. Maybe there's multiple people in those spots, but they're rare enough they don't even fit into the traditional range. The south location is the same. Overtime is super rare there. We only see 3 dots on this graph and that are all outside of the box and whiskers. The east location is the one that takes advantage of overtime. And so you can see here we have the first quartile and the median at 0, but we have the third quartile up here at 5. So what that tells us is half of the people who work at the east location who responded to the survey are working overtime. 25% of them have more than 5 hours, and we have one kind of outlier here at 15 hours. The rest are fitting here inside of this whisker. So we can use our box plot to compare our median, our interquartile range, the variability. Here, this is with interval or ratio data. Our box plot, as we said before, where's our box plot, can be used to show just one variable ordinal. It can be shown to, you can create multiple box plots to show ordinal data where it's in categories with nominal. We can also do our box plot with our ratio data. So the box plot can be used for any of those combinations. So we've looked at the histogram, we've looked at the density plot, we've looked at the box plot, and we've looked at the violin plot. So let's see, we should have a bee swarm left. And in fact, if you were looking at the inferential statistics videos, you've already seen a bee swarm. And the bee swarm allows us to look at the variability. The challenge, of course, with the box plot is we don't know how many people are at this dot. But with the bee swarm, we can see how many people are at a particular spot. So we use from Seaborn, import swarm plot. And to graph, we're going to use matplotlib.pyplot as PLT, so make sure you have your packages. Here we're using our coded data, but it doesn't actually matter because we're using question 24, which is the interval ratio number. So specify the table, data equals DFT, and then specify X equals what's the name of the column or variable in your data table. Here we have question 24, and we plot it. So a very simple bee swarm here. What this shows us is that one person is working for the company for 30 years. We can see that mode that we saw before with the histogram. We can see here it's not just between 0 and 5, but we can actually see it's probably about 2 years. That the majority of our workers in terms of mode are 2 years. But we also know from previous data that analysis we've done is that the average is higher than that because it's skewed by all of these individuals who have worked more years. So we can see the max, we can see the min, we can see the mode, and we can see where there's more common numbers. If you want to do a swarm plot for more than one variable, for example, we can look at number of years at the company, and we can break that down into the people working at the north location, the south location, the east location. Again, Seaborn import swarm plot and import matplotlib.pyplot, so make sure you have those. We've already loaded them, so we don't really need them again. And then swarm plot is the command. We need to specify the table. And here we use the second data frame, the second table that was coded, but it said it didn't matter here. Here we're using the first data frame. That's the one that if you look at it, df.head, that when it comes to question 23, it says east, north, south. So it's not coded. You can do not coded with your swarm plot. So swarm plot, data equals df, x equals 24. So whatever's on the horizontal axis is going to be the interval or ratio data. And then whatever's on the y is going to be your nominal. So question 23, and these are labels, right? The original data set has the words, the text. And then we'll put on the x-axis years of company, on the y-axis location, and we will plot the information. So you can see it doesn't have to be coded. If you do code it, you will need to go in and relabel what's on the y-axis. Otherwise, it's just going to appear as 1, 2, 3. So if it is coded, you'll have to change these. And so it just makes sense to use the uncoded if we already have it. So we have created, to show variability, we've created a histogram, a density plot, a bee swarm, a box plot, and a violin plot. So just before we leave this though, if you're wondering how you go about changing these if you have the coded data set. So suppose we were using data frame 2. I'll just show you quick here how to do this. If you're using data frame 2, then create a new table and replace the 1, 2, 3 with the names north, south, east. I recommend you do copy so that you're not actually changing the original data set here. BS, so our bee swarm here is a copy of data frame 2, which is the coded table. We're going to take column question 23. We're going to replace the 1s and make it north, the 2 make it south, the 3 make it east. And then we're just changing it in place. We're not creating a new variable. The rest is then exactly the same. And this would get you to, if you do this, that gets you to the exact same graph, but from the coded data set. In case you're wondering how you go about in changing these, you just change it in your data table before you go about plotting the information.